What is up, everybody? Zach here. Welcome back to Case Digital. In this video, we're going to start talking about some of the primitive data types or the main data types within Python. And the first off, we're going to start talking about numbers. Now, okay, I get it. Numbers, Zach, I learned numbers in elementary school. I know what a number is. And you're probably right. But in programming, we're going to talk about, especially in Python, the two main number types that we can use. Primarily, we're going to talk about the two main number types. We're also going to talk about the operations that you can do with those number types and when you can convert one number type to another number type. So, without further ado, let's start coding. Okay, so like I mentioned, there's two main number types in Python. And the first main number type is an integer type, or what we refer to as an int. And that's basically any whole number from negative infinity to positive infinity. And this can be things like -1, -5, -1 billion, +1, +7, 500 bazillion. Basically, it's just any whole number, just no decimal point. And that's where a float comes in. A floating point number, or a decimal point number, is called a float in Python. And so a decimal point number is anything basically like what it is, like what you learned in elementary school. It's going to be anything from negative infinity to positive infinity that includes a decimal point. So we're talking about like -0.75, 1.55, anything such as that. Now, let's hop right in. Let's get into some code, and I'll show you how you can tell if a number is of which type, and then we're going to get into the operations that you can use with these number types, as well as convert them. So let's hop right in and start coding. Like I mentioned, we're going to show you how you can tell if a variable or a number is of what type, and then we're going to get into some operations. And here's the operations that we're going to get into today, but first, let's declare a variable. So I'm going to create, and like I mentioned before, variables need to have meaningful names. Seeing as we're going to do some basic math operations, I'm just going to choose common variables like a and b or x and y. And I'm just going to go with, let's create a variable a, and let's assign that the value of 5. And let's create another variable b, and let's assign that the value of 2. And so with this, I want to check the types of what type, say, A is. And so to do that, I want to show it to the screen. So I want to do a print function, which will print everything out to the screen. I'm going to say, and then you can do the handy type, and then do a function, the type function, which is basically type, and then parentheses, and then you put in your variable or a number, and this will basically show you, it's going to print out what type is A. So now if we save that, and then we come down here, and we do make sure we're in the right directory, and I'm going to say, Python Datatypes, and I'm just going to tap complete and hit run. And it's going to show us that type A, or the number 5, is an int. Okay, so that shows that basically this whole number, like we discussed before, is of a type int. Well, let's happen if we change 5 to 5.75? We save that, and let's rerun it down here. And now it's going to show us that, hey, this is a float. So the type function is a way for us to help determine what, basically, as it specifies in the name, the type of the data it is. And so that's just one way if you need to know, like, hey, is my variable an int or is it a float right now? Like, that's one way to check. So let's jump into some of these operations that we can do. So you can do basically all the common math operations that you would with the number types. And so basically, if I want to do, so I'm going to say print. So we can show this to the screen. I want to do A plus B. Oops. Variables are case sensitive. Remember that. So we want to make sure it's lowercase b. Now, if I print this out to the screen, so it's going to say, and let's just do whole numbers right now. So it's going to say, what's 5 plus 2? And as we know, that's 7. Now, if I want to do minus, click on that, do minus 5 minus 2. Well, that's 3. Well, what about 5 times 2? Well, as we know, and what we learned in elementary school, it's going to be 10. And if we do division, now this is where it gets tricky. Well, it used to get tricky. In Python 3, it's not anymore. But if I do A, so 5 divided by B, which is 2, so 5 divided by 2, in math, that's going to be 2.5, right? Well, it is 2.5. Before, in Python 2, which you don't have to worry about, I'm just kind of giving you a little back history. Before, if you had two int types, like we've already determined A and B are both ints, when you did a division, it would basically do what's called integer division, which is essentially it would do the division and then just keep the whole number part. So you would say 5 divided by 2 would be 2 rather than 2.5 because it would do just the integer. Now, they've updated this in Python 3 so that a division just does regular normal division. And if we print out the type of this, it'll show that it's a float. So we take 2 ints and we convert it to a float. Now I'm going to do Command Z to do an undo to put us back to what we had. Now, if you do want to do integer division, or you want the int value of your division operation, you can do what's called floor division, which is basically just two backslashes, and from that you'll get A. So 5 floor division B, which will give you 2. And that just gives you that 2. So basically, you'll just round down to the nearest whole number, or give you the whole value for it. Now, there's some other operations that we can do, which are another one that is commonly used for checking if a number is even or odd. Is called the modulus operator. And that's just defined with this parentheses sign. So you do A, and you say A mod B, so 5 mod B, and that'll give us 1. Now what this does is give us basically the remainder value of how many times B can go into A. So for instance, 2, which is our variable B, can go into 5 2 times with the remainder of 1, because 2 times 2 is 4, and then that divided by 5, it has a remainder of 1 after it. And so essentially this is a good way to check if something is even or odd. And what I mean by that is if we changed our A variable to 4, and then we save that and then rerun it, it says 0 because 2 times 2 is 4, so there's no remainder, so that's 0. And we know that all even numbers are divisible by 2, and so I can check if it's even by just doing this modulus operator, and it'll tell us. And now if I do 6 and save that and run it, that's 0. If I do 9, if I do 9 and do the modulus operator and run it, it's going to be 1. We know 9 is odd, so that's just a good way to check there. Now, if you want to do an exponent, because you say you're writing out this big old long math equation, you want to do this exponent, you're like, well, how do I do exponents? Because normally I see exponents like this, right? Well, if we do this, it's going to give us something different. So this is a different operator than you would expect. Because we know that 9 raised to the power of 2 is not going to be 11. So just to watch out for that, that's just a different operator or a different thing that can be used. But the exponent operator is basically just 2 multiplication signs back to back. And when we do this, it's going to say 9 raised to the power of 2. So 9 times 9, which is going to be 81. And that's just kind of, I like that one, kind of cool. Just do times and go for it. And so that's kind of basically all the basic math operations that you can do. Now, one thing I will point out is Python works with order operations just like the order operations that you'd expect. So if I do 1 plus A times B, the order operation says do multiplication first. So it's going to do 9 times 2, then plus 1. So we should get 19. And if you wanted to do, say I wanted to do the A plus 1 first, then if you do the parentheses in that case, it'll do everything in the parentheses first, and then do times B. So you'll get 10 times 2, essentially, in this case, which is going to be 20. So just so you know, order operations works just the same as it normally does within the Python language. Now, a couple of things to point out, couple helper functions that I use and I like to use is kind of the absolute value function and the round function. So absolute value essentially is just ABS. This is a built-in Python function. If I do ABS of A, which we know now A is 9, so that's just going to be A, or just going to be 9. Now, if I do a negative sign or a minus sign in front of the A, that is one thing that's neat, is that's like basically saying -1 times A. So that's basically going to make it -9. Now, if I do the absolute value, just like from your time from learning what absolute value is in math in school, absolute value of a negative number is just going to basically be the positive form of that. So it's just going to be 9. So absolute value of -9 is just 9. Absolute value of +9 is just 9. And now get into the other one that's helpful is the round function. Now there is a word of caution that I have to throw out there with the round function, especially in Python 3, and I think 3.9 in this current version as well, is that it will round to the nearest number that goes into 10. So for example, if I have 2.5, or let's do this one first. So if I have 2.3 and I do the round function, obviously we know when you round, like from our math times, we know that 5 and above usually is what rounds to up. So if it was like 2.5, it would round up to 3. And anything below that, 4 and below, will round down, right? Well, interesting to note with Python in right now as its current state in Python 3.9 is if I do 2.5, you would expect this from your knowledge of math, and maybe if you're coming from some other programming languages, that this would round to 3. But what's interesting is it actually rounds to 2. Now, the reason being is that stated in their documentation, it says that it'll round to the nearest number that goes into 10. So, for instance, 2, like if it's at this half point, it rounds to the nearest number that goes to 10. So 2 goes into 10 better than 3 does, and so it's going to round to that. But if this is a 2.6, that will round up to 3. Now, if I change this back to this, but do it to 1.5, just from what I stated, this will round to the nearest number that goes into 10. That actually rounds up. So when you have the odd numbers that are at the half mark, so 1.5, 3.5, 5.5, and you do the round function on them, those will actually go up to the nearest number. So like this one, I'm going up to 2. If I do this to 3, this will go into 4. But now if I do the even numbers, say like 6.5, this will actually go back down to 6. So I don't know why they did that. That's just a gotcha that I want you to be made aware of, especially if you're getting some weird data. But one thing that's cool about this round function is, say I have this number, let's do 6.7598. And say I have, and it could be longer, whatever, but I only run it to like 2 decimal places. So if I only want this to 2 decimal places, what's nice about this round function that they've made and it's built in is I can do a comma, space, and then do 2. And now this tells the round function to round this number to only 2 decimal places. And so when we do that, it's going to be 6.76. And as you can see, it rounded the 9 with the 5 and rounded up. So that's a built-in round function. That's what you can do with that. And those are some of the basics ones I think you'll use and that I've used a lot. And so I just want to let you know about those. And now next, when we talk about operators with numbers, we're going to start talking about what you can do as far as comparison operators with numbers. Now, we'll get more into this, especially what's called one of the other main data types, which is a Boolean. We'll get into more of that when we talk about conditionals or control flow of an application. But I just want to show you these conditions now because you can use these conditions with numbers as well as you will other things in the future. So, for instance, one of the condition variables is equals, to check if 2 values are equal. So I can say, well, is A equal, and you do that by the 2 equal signs, to B. And now we know that 9 is not going to be equal to 2. And so when we run this, it's actually going to say, hey, that's false. That's going to be false down here. Now, what happens if I say, well, I want to see if A is not equal to B. So if 9 is not equal to 2. And we know that 9 is not equal to 2. And so that's going to say true. And basically, if this was 2, and we wanted to do the equals. Now, one thing to be careful of is when you do the single equals, that's basically saying assign the value of B to the value of A. So, or assign what's in B to A. So be careful there when you're doing these comparisons. You want to have the double equal signs. So when we say A is equal to B, we know that 2 is equal to 2, so that's also going to print out true. And then if we do not equal, then this will print out false. Now we can do the greater than or equal to. So what happens if, let's check the greater than and less than. So if I say A is greater than B, well, is 2 greater than 2? No, it's not. It's equal. Well, we can throw in the equal operator, the greater than or equal to operator. That's how that's written with the greater sign. Or if you want to do the less than sign, you can do that with that one equal operator there. And then we say, boom, it is less than or greater to that. Essentially, that's all the comparisons, that you'll use. there's several more that we'll get into when we talk about, again, like when we talk about Booleans and flow control of a statement or application, and kind of like the if-else statements. But these are the number types. We have our integers, we have our floating point numbers, and these are all the operations that you can do with them, as well as all the comparison operations that you can do with them. Now, the last thing I wanted to talk about before we leave is how you convert one type to another. So say I have a number, let's go 5.5, or let's do 5.6, whatever. So we have 5.6, and we know that A, the type of A, from what we said, is a float. From down here, it says it's a float. So, well, what if I don't want that to be a float? What if I want it to be an integer? Like, what do I need? What do I do to make it just 5? Well, you could do your round function and round down. Well, that would probably round it up, actually. But what you could do, essentially, is you can cast it. So converting one number type to another is called, what we call in software development, is called casting. So I'm going to convert A to an int. Now, in Python, there's keywords that for different things, and we'll talk about more. But one of the two of the keywords that we'll use today is called an int of 5.5, and an int, and then a float of, say, 2. So these keywords, when you wrap them with parentheses around a variable or a number, they will basically convert that variable or number into that type. So for instance, A is equal to 5.6. We know that that's a float as stated down here. Now if we do A of int, wrap that in that parentheses, take A, we're going to convert it to an int, and then we're going to print out its type. Now if we do this, this should tell us that it's going to take it to an int. Now what happens when we print that out? So if we just print out int of A, this will tell us that from what we have in this print, it'll tell us it's type int, and then it'll give us the number 5. So that's one way to basically get the int value, or the whole number value of a decimal point or floating point number, is just to cast it to an int. Well, okay, we've done that with A. Now what if we do this with, we turn B into a float? Because we know B is 2, and it's a whole number of 2. So let's convert B into a floating point number. Let's see what happens. So when we do that, we see that B, it was turned into a float from this one. But then look what it did. It took that int value and just assigned the decimal point and a 0 behind it to show that it's a float. And so that's what it'll do to cast it to a float. Now, when we talk about strings, which is probably the next data type that we're going to talk about, this comes very handy. And I'm going to show you real quick. Because say I have another variable C, and that is going to equal to a string, which I'm going to put in a single quote. And we'll get more into this later, but this is just as an example. And I say this is 5.5. Now, if I do the type, let's do this. If I do print type of C, we can see that that is string. So str is the type for a string. Now, if I want to add C, so that looks like this, plus B, you would, in your mind, you're like, oh, I'm going to add 5.5 to 2, that's going to be 7.5. Well, actually, when you try to add, if they're not number types, if you try to add two different numbers, or if you try to add a number type and a string type together, you actually get this. You get this error saying you can't take a string and concatenate it or combine it with an int. So what you have to do is convert it, that string, to a float. You have to cast it to a float or an int. So in this case, we're going to take our C, convert it to a float, and then add it to our int value of 2. So when we get that, you get 7.5, which is what you expected, but because this isn't a different type, you have to actually convert it to a number type to actually get it to work correctly. So without further ado, that is basically the number types that are used primarily within Python. So go ahead, practice a little bit, maybe take some equations that you've done some old algebra homework and write everything out, make an equation, see if you get it, and test your programming knowledge with it. And in the next video, we'll probably start talking about strings. But until then, keep practicing, have fun with this, and keep coding.